Welcome back to my YouTube channel. Today we will discuss the Euclidean algorithms. Okay, Euclidean algorithms say that n integer ab belongs to z. Okay, n integers ab belongs to z, and where a greater equal to b and greater than 0. Okay, by the division algorithm, this is written as there exists q1 q2 belongs to z such that a equal to b dot q1 plus r1. Okay, and if r greater than 0, then again by division algorithm we can also write b equal to r1 q1 plus r2. Okay, and continue this process, we can find a positive integer n such that rn equal to 0 for some n. Okay, and if n greater than 1, then GCD of AB equal to Rn minus 1. Okay, and also n equal to 1, then GCD equal to B. Okay, now how to apply this result for n integer AB? Okay, now suppose here integers, suppose two integers 803 and 154. Okay, now applying Euclidean algorithms. Okay, first step is 803 written as multiple of 154 plus some reminders. Okay, so 803 equal to 154 into 5 plus 33. Okay, here my integer a, and this is b, and this is q1, and this is r1. Okay, here r1 equal to 33, which greater than 0. Okay, now second step, if r1 greater than 0, then b written as this form. Okay, are given r1 greater than 0. Okay, so b, this value also written this form. Okay, so 154 equal to 33 into 4 plus 22. Okay, and here r1 and r2 here. Okay, here my r1 and this is r2. Okay, now r1 can be here r2 equal to 22, which is greater than 0 also. So now again r1 can be written as this form. So 33 equal to r2 into 1 plus 11. Okay, written as this form. Okay, here my r1, here r2, and this is r3. Okay, and r3 greater than also 0. So now r2 written as this form. So r2 equal to 22 equal to 11 into 2 plus 0. Okay, this is r4 equal to 0. Okay, and now applying this Euclidean algorithms, here when rn equal to 0, then rn minus 1 is a GCD. Okay, so here GCD of 803 and 154 equal to r3, this is equal to 11. Okay, so Euclidean algorithms using for finding the GCD of the any integers. Okay, any positive integers. Okay, in this process. Okay, thank you.